Hello everyone. So today we're going to solve problem number 2483, minimum penalty for a shop. So let's first read the problem statement. So here you are given a customer visit log of a shop represented by a zero indexed string customers consisting only of characters n and y. If the ith character is y, it means that the customers come at the ith hour, whereas N indicates that no customers come at ith hour. So Y means some customers come, and N indicates that no customers come at this hour. If the shop closes at the jth hour, and j can be between 0 to n. So here it is to be noted that it's less than or equal to n. So the shop can close from 0, 1, 2, 3, or 4. You can also close off after the hour. The penalty is calculated as follows. For every hour, when the shop is open and no customers come, the penalty increases by 1. So when shop is open and no customers come, that means it is n. Then penalty increases by 1. For every hour when shop is closed, so shop is closed and some customers come, that means there should be y. The penalty increases by 1. So what we need to do, we need to return the earliest hour at which the shop must be closed to incur a minimum penalty. So what we need to find is the earliest hour, and also note that if a shop closes at the jth hour, it means the shop is closed at the hour j. So what we can do is, looking at the first example, we have y, y, and y. So what we can do, we can calculate all the penalties at each hour. So suppose if we can close the shop at 0th hour, what would be the penalty? So if we observe carefully, if we closed at 0th hour, it will be nothing but simply the count of y's to the right of this, starting from current index and all the y's present, because the shop is closed here, and if the customer comes and the shop is closed, that means y indicates the customer are coming. So if here we found y and y, so this will be the penalty cost, because here the shop is closed and customers are coming, so this is nothing but count of y's. So for 0 index it will be 3 because there are 3 y's, and closing at the first index or first hour will incur. So when we move from the 0 index, we notice that we also need to consider the what happened before it. So before this, the shop would be open. And what's the rule for open? If the shop is open and no customers come, then only the penalty will increase. So for open, what we have is the count of n before current will be the penalty. So what we need to do is count of n before and count of n y after the current index, including current index. This will be the penalty. But at the first index there is no 0, no n before, so we don't need to worry about that. So here are two y's only, one y, two y. So penalty is 2. At second index there are no n's to the left, so we don't need to worry, and to the right, including this, there is only one y, so penalty will be 1. Similarly, for the third index, there is one n present to the left, so we need to count it, and there is one y, including the current index, so the penalty will be 1 plus 1, that is 2 here. For the fourth index, we need to count the all the n's present to the left, that is only one n present, so it will be 1. So this is the thing to notice in this problem. And in the second example, we see that no customers are arriving. So if we close the shop at 0th hour, we would be incurring the minimum penalty, that is 0. Because if you open the shop here, this will cause a penalty, and this and this and this, and it will keep on increasing only. And in the example 3, we had all y's. So we need to close the shop after the hours, so it's 0, 1, 2, 3, 4, and 5. So if this was the example, then we need to close the shop here, because at every hour the customers are coming, so we need to keep open the shop for the customers. So the approach is very simple. The idea we use is this: we need a count of y's and a count of n's. So if we are moving from left to right, that is from 0th index, what we notice is we only need the count of y's. We can get the count of n's while we are moving from 0 to 1, then 2, and so on. So I think the approach should be clear now. Let's move to the code, and there it will get more clear. So first of all, what we need is, let's define an integer n. It will be the size of customers, the customers dot size. Then we need a variable to count the y's present in the string. So we will declare cy, count of y's. We will initialize it with 0. Then we will traverse the customers using for loop, for each loop. Then if x is y, we will increase the count of y. Now we have got all the y's present in the customers. Now what we need to do is, we need to keep track of the minimum penalty that was incurred. So we'll make a variable int min penalty, and we will initialize it with a much larger value. So suppose, looking at the constraints, we can see the value of penalty can go till 10 to the power 5 only, because at each step only one penalty can increase, and there the length is 10 to the power 5, so maximum penalty can be 10 to the power 5. So we can take 1 is 6, that is 10 to the power 6. Next, what we need a variable to store the answer, so we'll declare a variable answer. Let's initialize it with 0. Now what else we need is, we need a variable to keep the count of n's. So we will take cn, count of n, and we'll initialize it with 0. Now we simply need to traverse the customers. And one thing to notice here is, we need to go from 0 till the equal to n, which we have seen here only. See, equal to n. So we'll go from I0, I less than equals n, and I plus plus. Now at each step, we already have got the count of y's starting from this index, and cn will store the count of n's. So let's say int current penalty. What will be this? Current penalty will simply be count of y's plus count of n's. And if current penalty is less than, because we need to get the first penalty minimum, so we will use here less than, not less than equal to. So if current penalty becomes less than minimum penalty, we will first update the minimum penalty to be equal to current penalty. Then our answer will become I, and then what we'll do, we will check if customers at current index equals y. If it is y, what we need to subtract it, because if we move to the right, this should not be counted. So we will do cy minus minus. And if it is not a y, it should definitely be an n. So what we'll do, count of n plus plus. But we need to notice one thing, that here I will go till equal to n. So we have to check a condition, if I equals n, we can simply break or continue, either, both will do the fine. So we'll use here break only. Now we are calculating the penalty at each step, updating the penalty and the answer. So this should work just fine. Let's try to return answer and check the sample test cases. So sample test cases are passing. Now let's submit it. So it's passing, and now let's analyze the time complexity of this approach. So what we are doing is, we are traversing customers here once, then we are again traversing customers. So in total we are doing n plus n operations, 2n operations, that is the time complexity will be big of n. And what should be the space complexity? As we are using only constant space here, constant space here, and constant space only, so the overall auxiliary space will be big of 1. So thank you and see you in the next video.